Have you ever just looked around and thought about what everything is actually made of? I mean, from the skyscrapers we work in to the smartphones glued to our hands, our entire world is built from a choice between two basic teams of materials, metals and nonmetals. Today, we're going to dig into what makes them so different and, so incredibly important.
Okay, let's start with something super simple, something you've probably never even thought twice about, your frying pan. Why is the part that actually cooks your food made of metal, but the handle you grab is almost always plastic or wood? The answer to that simple question gets to the very heart of this material showdown.
So really, it all boils down to this epic battle of materials. On one side, you've got the shiny, strong superheroes we call metals. And on the other side, you have their just as important counterparts, the nonmetals. All right, first up, let's talk about Team Metal. These are the shiny heroes of the material world, and trust me, they come loaded with a whole set of superpowers that make them perfect for all sorts of jobs. So, what are these superpowers exactly? Well, for starters, metals are shiny, right? That's why we love gold and silver for jewelry. They're also incredibly hard and strong. That's what makes them the backbone of our cars and buildings. And then there's this huge one. They are fantastic conductors of heat and electricity. Why? Because they have this sea of what we call free electrons that can just zip around carrying energy with them. And finally, they're malleable. That means you can hammer a piece of metal into something like a car door and it won't shatter into a million pieces.
But out of all those amazing powers, their ability to conduct electricity, that might just be the most world-changing one of them all. It's a superpower that literally powers our entire modern life.
And this is a perfect example of why a specific metal is chosen for a specific job. Take copper. It's the king of wires for two big reasons. One, it's an amazing conductor. And two, it's also ductile, which is just a fancy way of saying you can stretch it into super thin wires without it snapping. It's the perfect combo for getting electricity from a power plant right into your phone charger. Oh, and the powers don't stop there. Some metals, like iron, are magnetic. A super unique property that's crucial for everything from the magnets on your fridge to the inside of electric motors. And almost all of them have really high melting points, meaning they stay solid and strong even when things get hot.
But, like in any good story, there's always an exception, right? A rule breaker. In the world of metals, that rebel is mercury.
Just look at this number. While most metals need hundreds, even thousands of degrees to melt, mercury turns into a liquid at a freezing -39 degrees Celsius. This is what makes it the only metal that you'll find as a liquid just sitting at room temperature. Pretty wild.
Okay, so our metal heroes seem pretty invincible, right? Well, not quite. Every hero has a kryptonite, and for metals, that one critical weakness is something called corrosion. So what is corrosion, really? Well, it's basically what happens when a metal is left out in the open, exposed to air and water. Over time, a chemical reaction starts to happen, and it literally breaks the metal down, making it dull, weak, and brittle. Now here's something a lot of people get mixed up. Corrosion versus rust. They're not the same thing. Corrosion is the general catch-all term. So when silver turns black or that copper statue turns green, that's corrosion. Rust is the specific name for when the metal iron corrodes. That flaky, reddish-brown stuff you see on an old bike chain? That's rust. So, how do we protect our metal heroes from this weakness? The game plan is actually pretty simple. You just have to create a barrier. Stop the air and water from ever touching the metal's surface. And we do this all the time by coating it with paint, covering it in plastic, slathering on some oil or grease, or even plating it with a different, more resistant metal.
All right, that's Team Metal. Now it's time to meet the other side, the nonmetals. If metals are the flashy superheroes, you can think of nonmetals as the versatile alternatives, with a completely different but equally crucial set of skills.
And you'll see right away, their properties are pretty much the polar opposite of metals. I mean, they're all around us. The carbon in our bodies, the oxygen we breathe, the plastic and wood in our homes. They're usually dull, not shiny. They're brittle. If you hit a piece of charcoal with a hammer, it's going to shatter, not bend. And here's the big one. They are terrible conductors. In fact, they're so bad at it, we call them insulators. And that right there, that poor conductivity, brings us all the way back to our frying pan. Being a great insulator isn't a flaw, it's a feature. That's their superpower. It's the whole reason the intense heat from the metal pan doesn't travel up the plastic handle and burn your hand. In this job, being a bad conductor is exactly what makes it the hero.
But hold on. Just when you think you've got the rules all figured out, it turns out the world of nonmetals has its own little surprise.
Let me introduce you to graphite.
You know it is the lead in your pencil. It looks like a nonmetal, it's dull, it's brittle, classic nonmetal. Except for one shocking twist. Graphite can actually conduct electricity. It's the one nonmetal that can hang with the metals in the electrical world. It's a total rule breaker.
Okay, we've met both teams. We know their powers, their weaknesses, and their secret exceptions. So, let's bring it all together for the ultimate showdown.
Let's put them head to head. Metals? Shiny, strong, and they bend when you hit them. Non-metals? Dull, usually weaker, and they break or shatter. And the biggest difference of all, metals are conductors, non-metals are insulators. They are two completely different toolkits for two completely different kinds of jobs.
So, at the end of the day, what's the verdict? Who's better? Well, that's the wrong question. There is no single better material. A steel bridge is a brilliant idea. A wooden one, maybe not so much. The whole art of science and engineering is about picking the material whose unique set of superpowers is the absolute perfect match for the job you need it to do.
And that's our deep dive. So now that you know the rules of the game, I want you to look around. Look at your chair, your desk, the window. What's it made of? And why is that material the perfect hero for that specific job? Think about it. Thanks for tuning in.